library. This is Dr. Pavitra, AC, Associate Professor, Department of CSD, ATME College of Engineering, Mysuru. Today, I'll be explaining parallel computing lab program on how to demonstrate MPA scatter and MPA gather. This demonstration of MPA scatter and gather theory says MPA scatter is a collective routine that is very similar to MPA broadcast. MPA scatter involves a designated root access sending data to all processes in a communicator. The primary difference between this MPA broadcast and MPA scatter is very small, but it is very important. MPA broadcast sends piece of data to all processes, while MPA scatter sends chunks of an array to different processes. Whereas this MPA gather, it is the inverse process of MPA scatter. That is, instead of spreading elements from one process to many processes, this MPA gather takes elements from many processes and gathers them to one single process. This routine is highly useful to many parallel algorithms such as parallel sorting and searching algorithms. Let us see the coding of this. So we are going to use MPA library header and the standard input output, and this is also a standard library for using parallel computing programs. And let us initialize with the main arguments of C and arguments of C in as an integer, and initialize the MPA execution environment, initialize the size and the rank ID. Now the MPI init, that is MPA execution environment, is initialized with ampersand argument C and argument C. So it takes the address of this argument C and argument V. Now get the total number of processes. So what are the total number of processes? That is indicated with communication size. And what is the total number of rank IDs? So that is indicated with communication rank. So that is current ID of the process, rank ID of the process. Now you have to declare the communication rank size with a global data 4. So here, if you want to declare array of this way, we can declare in the global, or else without using pointers we can even declare with the locals. Now this global, it is used with no pointers, that is it declares the array with no pointers, and the local, that is without pointers. So each process has its own local array here. Now initialize with the I. A code is executed only with the root process, that is one rank is equal to 0. Now initialize the global data with I and print that process has the data with the rank ID. For process I is equal to 0, I less than size and I plus plus, it prints that global data. So that is in the next line. Now here we are going to use MPA scatter. So for MPA scatter, this is the syntax we are going to use in parallel computing algorithms. So in this parallel processing, we are going to use MPA scatter. So that means this root process, that is root process is 0. The rank 0 sends one integer to each process. So each process receives one integer to local data, and MPA scatter sends this to global data 1, local data 1, MPA int with 0, communication 1. So each process prints the data it received. So here it prints the data it receives. You can modify the received data by changing the rank and print that particular modified data. Now MPA gather. So once all the process have scattered. Here MPI gather, this is the syntax which we use in parallel programming. So this MPI gathers all the scattered processes to one single process. So each process sends one integer to root, and root collects data into global data array. So now this uses the address of this local data 1 MPI int and the global data 1 with MPI int with 0 with a communication word. This is a communicator. So root process prints the final gathered data if rank is equal to 0, prints the final data, otherwise prints the global data and terminate MPI environment and finalize and return to 0. So the output will be like, so once it is run using the Ubuntu OS, MPI CCC, this is a compiler with -g and -o, MPI scatter gather.c, this is the program name, and run with the 5 process. So process 0 has the data that is 0, 1, 2, 3, 4. Now process 0 receives data 0, process 0 now it has 5, and process 1 has data 0, now it has 5, process 2 has data 0, now it has 5, process 3 has data 0, then it is now it has 5. So process 4 has the data that is 2, 5, 5, and finally now the process 0 has 5, and finally the process 0 has the data 5, 1, 2, 3, 4. So this is how the data is scattered and gathered. Thanks for watching the video. Thank you.